No piece of infrastructure highlights the hidden power of construction more than tunnels. From connecting remote islands to saving a city from flooding, some of the most incredible feats of engineering are happening right beneath our feet. Grab the popcorn, sit back and relax. We're going to dig into some of the world's most impressive tunnel building projects.
Except I'm not in the Faroe Islands. The B1M team and I have only made it as far as a hotel here in Copenhagen. That's because yesterday, having got up very early to fly from London to Copenhagen and work today in the airport and then expecting to go from Copenhagen to the Faroe Islands, everything got cancelled because of the weather and it doesn't look like anything's going to the Faroe Islands anytime soon. Now I promise you this little travel nightmare is actually relevant to the underwater tunnels on the Faroe Islands that we're going to tell you about. Now, when you think of the world's most impressive tunnels, the Faroe Islands might not be what immediately jumps to mind. But to connect 18 rugged bits of land formed from volcanic rock, they've had to get pretty good at tunnelling. Now they're working on their biggest project yet. This so-called jellyfish roundabout is a work of art in its own right. It's a critical piece of infrastructure that's cut travel time between two of the most populous islands from more than an hour to just 15 minutes. Welcome to one of the world's most impressive and remote construction projects. Life here in the Faroes moves slowly, but the weather moves quickly. Some people say you can experience all 4 seasons in a single day. That can make getting around a little difficult, or even impossible, as we learned just trying to get there.
The Faroes are known as the land of maybe. Now you know why.
The Faroe Islands sit between Norway and Iceland in the North Sea. They're a self-governing nation that's technically part of Denmark. In all, its population of just over 50,000 people and some 70,000 sheep is spread out across 17 habitable islands. Up until relatively recently, the only way to travel between them was to take a boat, but the water out here can sometimes be a little bit rough. Rolling waves aside, the journey itself can take up to half a day depending on when you catch the ferry or if it's even running. In the 1970s, a bridge was built connecting the two most populous islands, turning that half-day journey into just a few minutes. But it was back in the 1960s that the Faroe Islands began its tunnelling boom. With a little help along the way from the Norwegians, the Faroese got really good at digging tunnels. In the last 60 years, they've built 20 through narrow fjords, steep mountains, hills and the ocean. Today, there are over 50 kilometres of road tunnels for just 53,000 people. That's more than 1 metre of tunnelling for every person who lives here. Now, the Faroes is expanding its tunnelling system even further with 2 undersea tunnels. It's the biggest investment it's ever made, with a combined price tag of nearly $700 million.
It's just sort of surreal how it changes the geography, and places that have always, and in our minds, been separated by at least 50 minutes, all of a sudden are separated by 10 minutes or less. It's strange and wonderful.
The Eysturoy Tunnel opened in 2020 and runs for 11 kilometres to connect the islands of Streymoy, where the capital is located, and Eysturoy. The second Sandoy Tunnel is set to open in 2023, connecting the sparsely populated villages of Sandoy with the wider infrastructure network in Streymoy.
The Eysturoy Tunnel will shorten the distance for a big part of the population how to commute to the capital, Tórshavn, where all the public services are, hospital and everything else. A lot of the export from the Faroe Islands are going to and from Tórshavn, so investments like these are very important for the Faroe Islands, for how you can arrange and have an efficient society.
Taita is leading the construction of the latest undersea tunnels, which are part of a slow transition in how people get around here. Rather than driving cars onto ferries, now they can simply drive under the water. The Eysturoy tunnel connects more villages with the mainland and the island's main infrastructure. Travel times to the capital are reduced from more than an hour to mere minutes, and adding in some epic construction makes an already stunning drive even more breathtaking. The tunnel itself is the second longest in the world that you can drive through, and they've spared no detail. On the 8-minute journey beneath the sea, you can listen to a radio station specially programmed to enhance your experience. And of course there's that roundabout. 72 metres below the surface, you'll find this giant pillar of colourful rock that apparently looks like a jellyfish. The deepest part of the tunnel sits 187 metres below the water's surface. The team used a drill and blast method to excavate the area. Essentially, a hole is drilled into the rock below the water, the explosives are dropped into the hole, and then the rubble is cleared out.
When we are drilling the project, there are around 140 people or something like that connected to the project. But not everybody are working at the same time. The project is running 24 hours, which means that there are 8 drilling teams, 1 in each side, and then 2 are sleeping and 4 are off.
To make sure no water gets into the tunnel, the rock is sprayed with concrete to create a solid lining. There's also a system of gates, pumps and pipes that lead any rain or surface water away from the cars before then pumping it back out into the nearby fjord. In all, construction of the 10.5-kilometre tunnel took 4 years to complete. That's nothing compared to some projects in cities like New York and London, which can take far longer. Of course, there are far less people living above a tunnelling site in the Faroes, but there are some lessons to be learned here in how to build tunnels quickly and efficiently.
We are a small country, a small society, where decisions can be taken quite quickly. That's one reason why we can do projects like this. And also that we have good experience doing tunnels. We are building tunnel based on Norwegian standards, Norwegian technology.
The Eysturoy tunnel is expected to carry thousands of vehicles every day, and it'll cost a pretty penny at around $25 or $10 with an annual pass. But that toll revenue is going to be used to cover the cost of construction, maintenance, and future tunnel projects. The second tunnel, on the other hand, is expected to carry just 310 vehicles a day across 22 kilometres, making it the longest car traffic subsea tunnel in the world. And it comes with a price tag of nearly $500 million. It's a huge investment per capita, substantially more than other European tunnelling projects. But this isn't a densely populated nation, and it's going to make a huge difference for the people it does benefit. Right now, you have to take a ferry to get from Sandoy to the mainland. The new underwater tunnel will make a 64-minute commute just 16 minutes by car.
For the people in Sandoy, which has seen population decline since the 80s, I think, it means that the rest of the country cares about them or listens to their wishes. It's a part of the whole, seeing the country as one small unit and connecting it as one small unit.
It's a big honor to work on a project like this, and it's also a very big responsibility because it is an investment of around 7,500 euros per inhabitant in the Faroe Islands. So if you compare it to any one other country, it's an unbelievable big project.
It's worth noting that I'm not the first good-looking British man not to make it. The islands feature in the James Bond movie No Time to Die, but Daniel Craig was never on the actual islands due to a logistical challenge. For a quiet nation of just 50,000, the Faroe Islands is investing a lot of time, money and skills into its infrastructure, and it's paying off. These new tunnels can literally make the difference between getting to work, seeing family, or even reaching a hospital, or being stuck on the other side of stormy waters. With a further 2 tunnels now in the works and another 14 on the drawing board, the Faroes tunnelling boom isn't slowing down anytime soon. Norway is home to some of the world's most stunning scenery, but it's not exactly easy to get around. For centuries, humans have found navigating its network of glacial valleys known as fjords to be a serious challenge. But some massive infrastructure projects are now making this incredible terrain more accessible than ever before. A new coastal highway will transform road travel in the region, connecting 7 cities and eliminating ferry crossings, cutting journey times in half. And now a one-of-a-kind sea route's being built as well, the world's first full-scale tunnel, big enough for a cruise ship. It's been talked about for years, but now the Stadship Tunnel has finally been approved, and work will start in 2022. Costing over $300 million and taking 3 to 4 years to complete, the project will see a new mile-long shipping route carved under the Stadhavet Peninsula at its narrowest point. Now, we've built tunnels for boats before, like this one on the Canal du Midi in France, but the Norway project takes things to a whole different level. After all, there's a pretty big difference between a small tourist boat and a cruise ship. Measuring 37 metres high by 26.5 metres wide and with a depth of 12 metres, the tunnel will be big enough for ships up to 16,000 tonnes to pass through. This crazy project is the answer to a problem that's existed for more than 1,000 years. Quite literally since the time of the Vikings, traversing this part of the sea has meant a treacherous journey for boats. With frequent bad weather, tough tidal conditions and strong currents, this stretch of water is one that many ships' captains would much rather avoid. Bypassing it could be lucrative for the country's tourism sector, while other industries and trades would benefit from safer passage. It's an extreme challenge that's always required a pretty extreme solution. While the Vikings are thought to have managed by physically dragging their boats over the land, it's now possible to go through it, bringing a 2-hour trip down to about 12 minutes. Although contractors are yet to be appointed, the plan is for the upper section to be excavated first in a similar way to conventional road tunnelling, with underground drilling and pallet rigs. There's plenty of expertise for this in the area. Norway's home to over 1,000 road tunnels across the country. Construction's likely to start at opposite ends of the peninsula, creating 2 tunnels that join in the middle. The roof will then have to be reinforced with concrete for stability before service routes are added in, allowing excavated material to be carried out. Works will then gradually move downwards layer by layer. To dig out the tunnel floor, temporary barriers or cofferdams will need to be placed at each end of the terrace stone entrances, designed by Snehetta. These will keep the water out and allow the excavation below sea level to take place. When the work's fully finished and all the services like lighting are installed and working, the tunnel can be slowly flooded before the cofferdams are cleared away. In total, about 8 million tonnes of rock will be removed and partly recycled for future projects. That's equivalent to around 35 of the world's biggest cruise ships, or 106 million Tom Cruises. Taking material away from the site is far from simple due to the lack of decent road infrastructure around the peninsula, and barges could play a role in the process. As with any world first, extensive research and testing was done to make sure the project was actually possible, long before approval was given. This included building a mock-up of the tunnel at a test pool in Trondheim. By passing models of ships along it and simulating various conditions, researchers found that vessels could make a safe trip through the real tunnel without hitting the walls. A digital model of the tunnel was also used with a simulator to visualise how ships would approach it and to see how traffic could be managed. From this testing, a traffic light system will now be put in place, and 5 ships will be able to make the trip each hour with a distance of at least 400 metres between them. But this could be flexible. Smaller vessels may be allowed to go through side by side, which would boost capacity further. Recent events in Suez put the importance of all this testing into context. When things go wrong on critical shipping routes, the trade implications and internet memes can spiral. With preparations now done, all eyes will be on Norway from the project's start right up to its expected completion in 2025. If this Mission Impossible works, it'll surely only be a matter of time before other countries borrow the idea and try something similar. While the coastal highway is far bigger and more expensive, this project will be no less of an achievement. It may have taken a millennium to figure out, but building a whole new kind of infrastructure is rarely smooth sailing. Walk around the streets of Chicago and you'll see giant skyscrapers, Wrigley Field, and lots of deep dish pizza restaurants. But deep beneath all this, the city is hiding something more. 90 metres below your feet, you'll find a secret underground tunnel network that sprawls 175 kilometres beneath the metropolis and surrounding area. It's one of the largest civil engineering projects in the world. Construction's been underway since the 1970s, and it's a key tool in the fight against climate change. So what is this secret labyrinth concealed beneath one of America's largest cities? Why does it exist? And how exactly was it built without anyone noticing? We're heading underground to find out. Now, our built environment and the process of constructing it accounts for around 40% of all global greenhouse gas emissions. So, while many of us might not realise it, if we really want to tackle climate change, it's kind of essential that we build and use our buildings, cities and transport systems in a much more sustainable way. Our built world is critical in combating the effects of climate change too. Some of those effects are now inevitable, as global temperatures are predicted to rise by 1.5 degrees Celsius, regardless of the many actions being taken. Construction can help build a more sustainable world and protect us from the impacts of our changing climate. And America's Windy City is just one place deploying defences. Let's rewind a bit. Throughout the late 19th and 20th century, Chicago was rapidly expanding. But as its population swelled, infrastructure began having a hard time catching up. Chicago was built on top of a literal swamp, and as such its geography was very flat and low-lying, and that created severe drainage problems. Following storms, mud-filled streets and pools of standing water would form all over the city. Eventually, authorities decided to construct a comprehensive sewer system, but digging an underground system would have been too expensive, so Chicago just raised the whole city out of the mud by a couple of meters, added above-ground sewer pipes, and filled the gaps in with dirt. But as one problem was being solved, another was being created. All those newly laid sewers flowed directly into waterways that eventually flowed into Lake Michigan, the source of the city's drinking water. That caused a lot of disease among residents, so officials began looking for yet another fix. And if you thought raising the city off the ground wasn't ambitious enough already, then wait till you hear this plan. The Chicago River was reverse engineered. Instead of flowing into the lake, it was redirected into the Mississippi River. Now, changing the direction of a river works like this. First, a series of locks were constructed, along with a brand new 45-kilometre canal that sloped downhill. Pumping stations then directed water through the canal as it deepened towards the Des Plaines and Mississippi rivers, thus creating a reversal effect. To this day, the river still runs backwards. But as the population continued to swell, the sewer system that had once saved the city began getting overwhelmed. By the 1960s, sewers were overflowing more than 100 days each year. Flooding became more common, and Chicago once again found itself trying to solve a giant problem. So the Water Reclamation District teamed up with some other local entities and put a bold new plan into action. Enter the cleverly named Tunnel and Reservoir Plan, also known as the Deep Tunnel System. It's that 175-kilometre underground tunnel network set to feature no fewer than 3 reservoirs that goes right through the heart of downtown Chicago. It's meant to help manage the overflow and pollution issue. Any extra runoff water from storms could now be redirected through the new tunnels and stored in the reservoirs before being treated and eventually released. Construction began way back in 1975 with Phase 1, the tunnels themselves. Now, these weren't your average-sized tunnels back then. 4 distinct systems stretched up to 10 metres in diameter and under 100 metres of solid bedrock.
It was decided we're going to make the contractor use a tunnel boring machine to create these tunnels in rock. even though at the time more traditional drilling and blasting techniques may have been a little bit cheaper and more reliable. They thought, well, the machine is probably not going to cause as much damage to the rock as blasting would. So they were getting, maybe 50 feet of tunnel constructed in a day back when they started. And then by, within 10, 15 years, they're up to 150 feet, 200 feet per day.
By the time the tunnel network was finally finished in 2006, they could manage nearly 9 billion litres of water. That's around 2.3 billion gallons. It also helped reduce pollution by nearly 85%. And while the deep tunnel's construction wasn't originally built in response to climate change, it now finds itself as a critical tool in combating the effects of it. According to the latest national climate assessments, an increase in heavy rain and storms in the Midwest could lead to flooding, which may destroy property and contaminate drinking water. That's why Phase 2 of the project is becoming increasingly urgent. It consists of 3 massive reservoirs that allow the system to handle even more water. 2 of them are already complete.
We have these wheel gates that isolate the tunnels from the reservoirs. They operate only when the reservoir fills to completion, or if somebody's working there, we'll have to close it and isolate it. In addition, there's a grout curtain that surrounds the reservoir, and this is really to kind of seal the reservoir, almost like a bathtub. It's almost like caulking all the holes in the rock. So what we're doing is we're drilling down a hole almost 500 feet. It's about a 3-inch diameter hole, and we're pumping it with this grout material under pressure, and that seeps through cracks, sealing it. And they put these holes every 5 feet around the 3-mile perimeter of the reservoir.
So now, when it rains in Chicago, water first flows into the local combined sewers. These were originally directed into the rivers, but now that water is intercepted by the newer sewers. Then overflow shoots 70 to 90 metres down a drop shaft into tunnels deep underground. Here, water is pushed into the reservoirs where it's stored until the reclamation plants have enough capacity to clean it. That process normally occurs during dry weather or during moderate rainfall. Once the water is cleaned at the plants, it's steadily released into the river. When all 3 reservoirs are complete in 2029, the entire system will be able to hold over 64 billion litres of water. That'll continue to ease flooding and pollution after big storms. And even though construction works still have a few more years to go, Chicago is already seeing the benefits of its secret tunnel network. Less contamination has enabled more species to return to the waterways. Since the 1970s, the number has skyrocketed from 10 to nearly 80 different kinds of fish. Waterfront property construction is also booming, something that's been good for Chicago's economy. The city even built a brand new riverwalk with restaurants and bars that's become a popular walking spot. Now, 64 billion litres may sound like a lot of water, and it certainly is. But during big storms, the system can and will hit capacity. When that happens, it'll revert to the original process of redirecting the combined overflow into the waterways. That can cause polluted water to flood streets and basements, and further effects of climate change could of course make that a much more regular occurrence.
We have a very good model of our entire sewer network and tunnel system that we use to sort of simulate what-if scenarios, and we look at potential expansion of the tunnel and reservoir plan. But really right now we're looking at using a lot of green infrastructure. It's trying to simulate nature by having water kind of stay where it lands by infiltrating it into the ground, sending it through bioswales or rain gardens or things like that. And really the idea is to keep it out of the sewer itself. If it doesn't make it to the sewer, then it's not going to make it to the waterway, or it's not going to back up into somebody's basement.
For more than a century, Chicago has continued to build its way out of problem after problem with some of the biggest engineering projects in the world. But unlike before, preparing for the impacts of climate change is a moving target. It's an event we can see happening across the world with a future we have no precedent for. And we'll need to prepare our cities for it in a variety of ways.
The tunnel and reservoir plan is just one of them, and it's a project that many other urban areas could learn from as we fight the impacts of a changing climate together. Construction is central in ensuring a sustainable future for us all. While we may all see and feel increasingly common storms like these, Chicago's way of dealing with them is much more tucked away. It shows once again the remarkable power that construction has to shape, change, and save our world, even if you can't see it happening. Welcome to the Susa Valley in northern Italy, a picturesque mountain region close to the border with France. Life here is quiet, peaceful and easygoing, but below ground one of Europe's biggest construction projects is gathering pace. In just a few years, a massive high-speed railway will pass through here as part of the new Trans-European Transport Network. But there's one little problem standing in the way: a massive mountain range. To conquer this terrain, construction crews are having to dig deep, tunnelling further than ever before. But the scheme's faced heavy opposition and some pretty huge challenges. This is how the world's longest rail tunnel's being built, right through the middle of the Alps. If you want to travel between two of the biggest cities in France and Italy, then it might look quite simple at first. They're only separated by a few hundred kilometres. But in reality, the train takes around 4 hours to cross the mountains. Much of the long and winding route was constructed centuries ago, and according to some, it no longer meets international standards. The Frejus tunnel has been around since 1871, but today it's simply not wide enough. There's only a single tube, and the line was built on a slope, so trains are using more energy than they would on a flatter surface.
Because the original lines that uses these passes like the Brenner, the Simplon, the Gotthard, and the Frejus are lines that were built in the late 19th, early 20th century, and they were built to a different standard and grade. So they were mountain lines. So they have steep grades, and sometimes they are not suitable for modern freight traffic.
And yet, despite its downsides, many people still have a soft spot for this historic piece of infrastructure, which was upgraded for modern trains back in the 2000s. At the time of its unveiling, it became the world's longest rail tunnel, where techniques like pneumatic drilling and dynamite excavation were pioneered. But over time, the line has seen a lot less use, and now it's having to make way for something much bigger. Since 2013, work's been underway on the Trans-European Transport Network, a huge web of new and upgraded transport links all over Europe. There are 9 main routes in total, including the giant ScanMed corridor running all the way from Finland right down to Malta. Now, I know we've covered that already. It's where the Fehmarnbelt Fixed Link and the Brenner Base Tunnel, a 55-kilometre railway through the Alps, are all under construction. But to complete the 3,000-kilometre Mediterranean corridor, which goes from east to west and connects Hungary to Spain, an even larger hole is needed: the Mont Cenis Base Tunnel. It's the main engineering section of this new rail link between Lyon and Turin, which has been talked about since 1990. At 57.5 kilometres, it will take the title of world's longest single rail tunnel when finished, barely beating Brenner and the Gotthard Base Tunnel, which completed in 2016. Cleverly called the Lyon-Turin line, it will use modern methods of construction to go much deeper underground than the current railway, meaning no uphill climbs and a more direct route. But it also means tunnelling through a lot more mountainous rock.
That's the reason it's called a base tunnel, because instead of gaining heights, going up the valley and trying to get to the shortest point possible to go across the mountain, the steepness of your line has to be very low. Of course, you have to be in the base of the mountain. So your tunnel gets, instead of 13, it gets 50, 55, 60 kilometers, as most of these base tunnels are.
Built for passengers and freight, it'll stretch for over 270 kilometres in total, with 70% of the line in France and the other 30% in Italy. Construction and management of the cross-border section is being handled by the Tunnel European Lyon-Turin, or TELT, co-owned by the French and Italian governments. There's a joint approach to the funding too. The whole line is set to cost around $27 billion, with $9 billion going on the main tunnel. 40% of the money is coming from the EU, with Italy putting in 35% and France the remaining 25%. Not only is the new line a key link in the European network, it promises big environmental benefits. Once operational, the railway is predicted to take over 1 million trucks off the road, which would reduce CO2 emissions by 3 million tonnes a year. Then there's the time saving. It'll knock 2 hours off the current travel time between the two cities. With the new tunnel, it's fair to say that technology has moved on a bit, but for a lot of the work being done so far, the idea is actually quite similar. To get through areas of particularly hard ground, construction teams are still using the traditional drill and blast approach. This involves a combination of large drilling machines that carve their way through the rock and good old-fashioned explosives. But of course, on a 21st century megaproject like this, newer methods are being implemented too, including massive tunnel boring machines or TBMs.
So you cannot really use one only method of excavation. You cannot have a proper knowledge of what's underground because you cannot do this normal coring and sampling you do for like subways, where you just go on the surface, you do some sampling down the ground along the route that your subway will take, that will go like 15-20 meters below the ground. What they do is this like exploratory tunnels, so a lot of this work has been done, and this is to know what's inside. I mean, you have to dig before you dig.
Of the 162 kilometres of underground sections that need to be built overall, including all the access tunnels and shafts, around a fifth have been completed, with much of that construction work done between 2015 and 2019. For a while after that, not a great deal happened, partly due to the pandemic, and it hadn't been decided which companies would be carrying out the remaining work. That was until 2021, when 3 massive contracts were signed, but only in France. Now, the entry portal and the main tunnel are underway. The plan for completing the construction works over in Italy is due to be announced sometime in 2023. On the base tunnel itself, there's quite a long way to go. Only just over 10 kilometres has been completed in one direction on the French side. That was done using a TBM fantastically called Federica, which spent 3 years burrowing through the mountain's most complex geology. Once finished, it was taken apart and removed through one of the shafts that had been built earlier. A further 7 TBMs are going to be used on the rest of the project. Now, to create a tunnel like this, it's not all about digging horizontally, you've got to go upwards a bit too. Why? Well, because you need ventilation, mainly so that the air is breathable and free of smoke if the tunnel needed evacuating. At the Mont base tunnel, 4 ventilation shafts are being constructed, each 5.2 metres in diameter and 500 metres deep. That's more than the height of Shanghai's World Financial Centre. They're made by drilling a narrow hole from the ground right down into the tunnel, where a special cutting head is then attached. The result is what's called a raise boring machine, which excavates the shaft from the bottom upwards. There's a lot of work to do here, but then it's still early days. The line is set to finish in 2032. Now, if you've watched 1 or 2 of our videos on huge infrastructure projects, you'll know there's usually some kind of opposition, and the Lyon-Turin Railway is absolutely no different. But this one really has faced a lot of backlash over time. In Italy, a movement called No TAV has been campaigning against it for decades. Its place of origin? Well, the Susa Valley. TAV stands for Treno Alta Velocità, meaning high-speed train. The group's organised several protests, some involving tens of thousands of people and others sparking clashes with police. They say the line will do too much damage to the land and that the money could be better spent on other services like hospitals. Although changes to the route have been made to address their concerns in the past, many remain firmly against the project. There's been resistance over in France too, with even the mayor of Lyon calling for a stop to the project. Opponents have criticised the environmental impacts, believe funds should be redirected towards the existing line, and claim millions of euros intended for rail infrastructure in the region has gone towards roads instead. Despite all this, with support continuing from both governments and the EU, the project is pushing ahead.
I think this was a bad political choice to tout this project as a high-speed line, because it is not really. As much as I think that there is a market for high speed between Italy and France, it's not as big to justify a whole base tunnel. But if it's like it was done in Switzerland, the Gotthard-based tunnel was not done for the 2-3 passenger trains per hour that they used it, but for the hundreds of freight trains per day that use it to go from northern Italy to Germany and reverse.
Yes, it may have come under more pressure than normal, even for a high-speed railway, but the Lyon-Turin line is now picking up speed. And let's hope it's not another couple of decades before it completes. Promising lower carbon travel and trade, and providing a missing piece of Europe's transport puzzle, there are plenty of positives for both countries and the wider continent. The communities caught in the middle might not agree, but as a construction project, you probably won't find many more impressive or ambitious. The ScanMed corridor runs from Finland all the way down to Malta, and thanks to a bridge over the sea at Copenhagen, it's all pretty easy going, until you reach that rather large mountain range called the Alps. For decades, that's slowed travel down, creating a torturous bottleneck on what's otherwise a very slick route. To solve the problem, the EU is now digging an $11 billion tunnel directly through the very heart of the mountains to effectively link Scandinavia with the Mediterranean. It's an astounding feat of construction that will better connect a continent. Believe it or not, this picturesque valley is actually one of the most important links between northern and southern Europe. Sitting 1,371 metres above sea level, the Brenner Pass is the lowest passage through the Alps and can be used all year round. In 1867, the Brenner Railway was built to improve capacity, and by the 1970s it was joined by the E45 motorway, creating a major freight thoroughfare for traffic heading from the North Sea down to the Mediterranean and vice versa. Today, the Brenner Pass carries 40% of all freight over the Alps, but due to the steep inclines that you'd expect to find in the Alps, and the impact that has on reducing the speed of trains, over 2/3 of freight actually travels by road. This, combined with the leisure market in the region, made the area notorious for traffic jams, noise and poor air quality, and in 1994 the EU decided to take action. Modifying the existing railways is pretty impractical due to the terrain, so the decision was made to construct an entirely new railway directly through the mountains, somewhat dramatically getting around those steep inclines and meandering routes that slow trains down. Starting at Innsbruck in Austria and connecting to Fortezza in Italy, the main route of the Brenner-based tunnel will run for 55 kilometres. When connected to the Innsbruck bypass tunnels built in 1994, the project will become the longest underground rail connection in the world, with a total length of 64 kilometres, surpassing even the Gotthard-based tunnel in Switzerland. The overall project consists of an exploratory tunnel used to gauge the route's conditions prior to construction and to act as a drainage system on completion, twin main tunnels set 70 metres apart which will carry trains in either direction, and 4 lateral access tunnels that connect to the surface and allow for spoil and materials to be moved in and out. If that weren't enough, the 2 main tunnels are connected every 333 metres, and 3 emergency stations have been constructed 20 kilometres apart to provide escape routes and refuge for passengers. Works first began in 2008, and excavations now been progressing across 4 main sites for more than a decade. It probably won't surprise you that digging a long tunnel through a mountain is not easy, and this is no exception. The route happens to run through 4 distinct rock types and one of Europe's longest fault lines, so construction of the tunnels consists of a roughly 50-50 split between traditional blasting and the tunnel boring or TBM methods. For sections created by blasting, explosives are loaded into pre-drilled holes and detonated. Loosened material is then removed with heavy machinery in a process known as mucking.
Once cleared, shotcrete is applied to stabilise the surface and anchors, and lattice arches and reinforcement mats are installed to provide structural support. The whole process then moves forward and repeats itself. The TBM sections are, in principle, much simpler. The machine excavates material, removes it via conveyor belts, and applies tunnel reinforcement itself as it moves forward through the rock. Regardless of which method is used, once excavated, the tunnels are completed in largely the same way, with only minor differences to their final appearance. With an inner diameter of 8.1 metres, the project will see an incredible 21.5 million cubic metres of material excavated altogether. We're not sure how many yodels that's equivalent to, but it's a lot. Around a third of this material will be recycled, reused as concrete aggregate within the tunnel itself. The rest will go to 5 sites along the route to be disposed of in a sustainable way, acting as fill for areas that can be reforested and landscaped once the project is complete, returning the site to its original use. When it finally completes in 2028, some 20 years after construction first began, the incredibly direct Brenner base tunnel will allow trains to reach 200 kilometers an hour, and the journey from Innsbruck to Vorteza will go from 80 minutes to just 25. It's a feat of construction that'll create a cleaner and more sustainable transport link, not just through a mountain range between two countries, but from Scandinavia all the way down to the Mediterranean.
I'm in a huge tunnel deep beneath Austria. Soon cars are going to zip through here without realising that this space used to be solid rock. And that's all made possible by this massive 250-ton piece of kit.
You won't find this on many construction sites. It's a one-of-a-kind machine that was built especially for this project because this isn't how you'd normally dig.
If you've ever driven through a tunnel and wondered how it got there and why it isn't collapsing, it's because of seriously impressive work like this.
Crews here are pushing day and night to carve a path that better connects this Austrian city with a massive new suspension bridge. It's a challenging, twisting, and high-stakes infrastructure scheme that's about to impact the lives of millions.
Now, if you want to get around here in Linz, you could take a streetcar, walk, cycle, or drive. But there aren't many ways to get across the Danube, so the city is building a brand new 305-metre suspension bridge. But to build above the water, you actually have to get there first. And there's one little problem standing in the way. These massive rocks.
So the team here in Linz is tunnelling through them to connect the existing highways up to the new bridge. They're basically trying to build a simple slip road, but inside a massive cliff formed of solid rock, and on both sides of the river. Now, here at the B1M, we kind of know a thing or two about how to build a tunnel. Time for another quick Engineering 101. First choice for a tunnel these days is probably going to be a tunnel boring machine, or TBM. You know the ones. They're massive tube-like machines that eat through rock and then seal and line the newly formed tunnel with prefabricated concrete segments all in one go. TBMs are great because they're efficient and can travel underground without anyone living above really noticing. Like under ancient woodlands, or beneath the city that never sleeps. But they're pretty expensive. One of the nearly 1,000-ton TBMs used on London's Elizabeth line cost £10 million. So if you're splashing out for one of those bad boys, you'd better be getting some serious mileage in. And since they can be so big, and we mean really big, up to 15 metres wide and nearly 200 metres long big, they're great for tunnelling long stretches of a relatively straight path. Sounds like a no-brainer for a big infrastructure project, right? Well, yes. But here's the site in Austria. Just 1,600 metres of nothing but twists and turns through solid rock on the bank of a river.
So rather than trying to manoeuvre a giant TBM through it, construction here went a little more like this. This is the alternative, and quite frankly much more fun way to build a tunnel. Granted, it's not quite so subtle, but it gets the job done. In incredibly simple terms, you drill some holes in the rock, drop some explosives in, stand very far away, hit a button called detonate, clear out the rubble, and repeat the whole thing until you have a tunnel. When we say you, we don't mean you. Please, please, employ professional engineers and construction teams. The tunnels here in Linz were built using the new Austrian tunnel method. First, the path was cleared using drill and blast, with the debris taken away by boats along the river. Then, anchors and drainage points were installed, concrete was sprayed onto the walls to create some initial stabilisation, and these giant yellow waterproof sheets were installed.
But that's only half the battle. Once the tunnel's actually built, the team have to line it to create this nice, smooth finish. Now, you might think it'd be cheaper and easier to just leave it as exposed, craggy rock, and that would be the case, but that would be pretty dangerous and create a long-term maintenance issue. Rocks could fall into the tunnel at any point over the tunnel's lifespan. What you want is it looking nice and smooth like this.
That's where this thing comes in. It's an absolutely enormous 250-ton piece of equipment developed by Perry Formwork Systems called a formwork carriage. And it's been custom made for this site.
This is our formwork. We used it to concrete the whole tunnel, the walls. We used it for over 180 different sections.
Here's how it works. First, all the parts of the machine are brought in by truck and assembled. Then workers prepare it by shrinking it down enough to move through the tunnel. They'll remove the front bit called the stop end, close the wings, lower it down towards the ground, and roll it on through. Once it's inside the part of the tunnel that needs to be lined, the wings will expand until they're very close to the existing hard rock. Concrete is then pumped up and through into the space between the formwork and the rock. It moulds into the smooth curved shape of the formwork and gives the tunnel its nice lining. Then it's a waiting game. The concrete needs to cure overnight, so the formwork stays in place until the morning when it can be safely shrunk back down and move forward to the next part of the tunnel. Even the slightest delay in the schedule during the day means the concrete won't be cured by the following morning, which means the whole project gets thrown off. No pressure then.
What's been the hardest part of this project from your perspective?
So we have not a lot of space to work with. That's a really tight curve. The inner side of the curve is shorter than the outside of the curve. So we had to adjust the framework to concrete on one side a longer section and on the other side a shorter section.
Now, when it's at full length, Perry's machine can work in 12-metre stretches. But because there are such tight corners on this route, sometimes the team needs to cut the machine in half and pour even smaller 6-metre slithers of concrete to create a curve in the tunnel.
Now, you might not notice when you're driving through, but when you look closely, you can see the tunnel is actually formed from a number of smaller segments that are all fused together to help create that angle. What's been the best thing about working on this project? What have you most enjoyed?
Every day brings a new problem or something new to think about.
When it completes, millions of people will pass through this tunnel, and the immense effort that went into building it will be taken for granted. It shows once again the power of construction to shape our world, and the amount of innovation that's sometimes happening right beneath our feet. This video was made possible by Perry Formwork Systems. You can learn more about them and their massive machine at the link below. There's also the chance to go even deeper into this tunnel over on the World's Best Construction podcast, available right now wherever you get your podcasts. And as always, guys, if you enjoyed this video and you want to get more from the definitive video channel for construction, from the channel that takes you down Austrian tunnels, hit that subscribe button.